Okay, so now I've decided to make things a bit more interesting, and we're now going to configure an operating system, a real-time operating system. So we'll be using the real-time operating system from now on. So in order to do that, you'd have to enable the CM6 driver, and we'll be using the version 2 drivers actually. So now, so the first, okay, usually the default settings are okay. Everything else is fine unless you want to increase the stack or the memory allocation. But okay, entrance should be okay. There's usually a warning it tells me, but I would leave that for another day. So as you can see, it has already created a task called the default task, but I don't want to use this task because I want to illustrate some other processes later on. So I'm going to create a new task and I'm going to name the task, okay, let me just call it my task. With priority should be, so she set it to normal, otherwise it will barely execute. Generally, you want all your tasks to always prior to normal. Okay. And then the amount of stack size in words, I think a word is like 32 or 64 bytes, I'm not so sure, but this should be okay. So then the task function is going to be start my task. Okay. And then the code generation part, I want it to be external because we'll be creating our own function, or we'll put the code in a separate source file, and no parameters and everything is fine. And then okay, then we generate the code. Must be set. Yeah, okay. I was talking of the warning, so we need to configure. Must be re-entrant. Re-entrant. We must enable re-entrant. Okay, so now you will see that a lot of things have actually changed. So if we go back to our main file, so our app initializer is still in there actually, so but we don't want to put it here any longer. And okay, and okay, so this part of the code will never be reached actually. Once the code will now be ending from okay, OSKL start. Okay, and then now if we go to our FreeRTOS code, so you'll see it has created two tasks, and it will invoke this start. Okay, to create this thread which starts my task. So but now this one has only been declared as an external function, but we don't have it yet. So we're going to create this function inside our app. Okay, so what is the name of that? So now inside our app, we need to implement this function. Okay, that is all we need to do now. That's fact, and then now from now on, our code will be running from that side. So always delay one. That is the only thing. Let me just copy the old template. Okay. And then now we invoke our app initialize function from our thread. Initialize. And our app loop function from our thread as well. Or our app update, rather. And there we have it. So now our code is going to be invoked from this thread. So which is why I was saying that it is usually like a good idea to have like many delay functions for each thread. Because if you invoke this function from this thread, then on the default task, actually, you say yeah, halt. That's why they use always delay. So so always delay is like thread safe. it would prevent like a race condition where two different threads will try to invoke the same function. And so let me just try to illustrate what would actually happen. Let's say that the default task calls this function, and then maybe it gets sketched out while it is still waiting for it for milliseconds to be what to for the delay to finish actually. And then now the other thread, now our upper thread is now invoked. It calls the delay millisecond function. So actually, then it actually messes up the value of this milliseconds value. Then when this task returns to this function now, the value of milliseconds has changed and a lot of things have changed actually. So that is what you call a race condition in multi-threading, and you generally want to avoid those situations. And then another thing is I actually did not compile the code actually for the last application. You only just needed to fix this error and put this halt timer over it. So now if we compile the code now, okay, so it's OS delay. Okay, so we need to include the real time OS. This is the free root again. All of this, we just need to include all of this inside our app, and everything else is fine. So this is basically how you create your own task on STM32 IDE, and thanks for watching.